Hello, I'm Yuri, and I would like to show you some calculations why wind turbines are doomed as a source of electricity. Let's start with a simple task. How many wind turbines you need to power a city of 20,000 households? Average household consumption is roughly about 500 watts. So to power the city, you on average need 10 megawatt of electricity supply. Modern grids provide very high level of electricity availability. It is in the range of 99.99%, and this kind of availability spoiled customers. Customers expect this high availability of electricity. Let's imagine that you don't have a 99.99% but just 99% availability. What does it mean? It means that during the year you will have almost 4 full days when you have no electricity. It's absolutely impossible. Nobody will agree. You will sue your electric company, you will sue your grid if you have such a kind of availability. So, if you want to provide electricity, you need to have this 99.99% of electricity available in your mains. Unfortunately, wind turbines are not they provide electricity with certain probability. Let's have a look on this slide, and in this is a slide taken from the Dogger Bank. This is a location of major power plant, major wind turbine farms supplying electricity to the Germany, and those figures are from very reliable source from which collects data about the electricity supply to the Germany. And if you calculate this availability based on this graph, you will see that wind turbines probability is roughly about 40%. How many? So the idea is, if you combine several wind turbines, how many wind turbines you need still to provide all your electricity needs with a 40% availability? And the rough image is maybe you need 2 or 3 turbines. So let's make those estimates. Let's put them on a graph and see how many you need. For example, you have a source, say 70%. How do you supply electricity to your grid? You have a 100% capacity. You have a source of electricity 70%, so you still have like a 29.9% of electricity which is not available. You can put another source, say another 10 megawatts or whatever, and to cover this probability of 29%, 29.9, and it will be still the probability of 70%. So the total capacity, total availability of your net would be 90.93%. Let's put third source on it, and if we put a third source on it, we will see that total availability will be 97.27. Still, we will have like a 2.5% of probability of failure. What does it mean, 2.5% of probability of failure? It means that roughly 12 days during the year you wouldn't have electricity in your net. Whether it is acceptable? Very, very unlikely. So let's have a look on how traditional grid is working, and what is happening here is that grid normally receives electricity from very reliable source like a nuclear power plant or coal power plant or gas power plant, where the probability to supply electricity is in the range of 99%. Oh, and please don't confuse the probability or availability of electricity with capacity factor. It's absolutely different parameters, because the capacity factor basically means your downtime, and in the case of power plant like nuclear power plant or coal power plant, your downtime is very easy to predict. So it is quite different from availability. Availability is a situation when you need electricity. You want the electricity source, you warn them beforehand that you will need electricity this time, and they provide you. And in the modern power plant, the availability is 99%. So to provide the 99.99 probability of electricity in your mains, you basically need two power plants. So in the unlikely event of 1% of power plant not working, you always have a backup power plant, and so the availability factor is calculated by this formula, and this is basically 99.99% probability. 99.9% probability. So how many wind? So let's replace the wind turbines. Let's replace our nuclear power plant with wind turbines. So how many wind turbines we will need in a situation when we have the wind is the only source? So it means the probability to supply electricity is 40% and probability to fail is 60%. So it means that 200 days during the year you wouldn't have any electricity. That's exactly what happens if you try to supply electricity only from Dogger Bank. Let's put second turbine here, and you will see that probability is increased to 64%, and still probability to fail is at 36%. Let's put, and we can continue calculating these probabilities, and this is a chart how it will go, and you will see that only when you have 18 or 19 turbines working in parallel on your grid, you will reach the modern day probability. And very important thing here is that those wind turbines cannot be located into one place. They must be statistically distributed, because the concentrated wind turbines like Dogger Bank, they all situate in the same climate, in the same geographical situation, in the same weather. To provide statistically unbiased power source, you need to have a location in the Dogger Bank. You need to get electricity from the Spain. You need to get electricity from the Indian Ocean, from Arctic Sea, from Antarctic Sea, from everywhere in the world. And in this case, you will have a statistically unbiased sources of electricity. So our imaginary town with 20,000 households should have a power cords should have 18 power cords going to all the places in the world, everywhere. And whether it is possible or not, I don't know. So here we are. So what does it mean? What does it mean, those 18 wind turbines to supply just 18 turbines to replace the equivalent energy? In the case of so Germany is very proud about their installed capacity. So they claim that they have a 59 gigawatt of installed wind capacity, and by the way, this 59 gigawatt of installed wind capacity cost 150 billion euro. But as we can see, that those 59 gigawatt will eventually the ability to produce power should eventually be divided by 18 or 19. That's what I call capacity adjusted factor. So that means that 59 gigawatt of installed capacity in Germany actually equivalent 3.2 gigawatt of electricity. In fact, even less, because they contact it. Present day German consumption of electricity roughly equals to 59 gigawatt of electricity, and this is how this figure is calculated. Is a very simple, the capacity, the total electricity that Germany calculates is divided by 8,760. That's the number of hours you have in the year. And to replace this 59 or say 60 gigawatt of electricity with wind turbine for total replacement, you will need almost 1,000 wind turbines. 1,000 gigawatt, and basically one terawatt of capacity. And 1 terawatt of capacity in present pricing equals to 2,500 billion euros. That's it's almost 20 times more than have been invested so far to the system. What is the conclusion of what I explained?